In this experiment, we shall determine the focal length of a converging lens. For this experiment, we require an illuminated object, a converging lens in a lens holder, a ruler to measure distances, and a screen to capture an image. Before we start the experiment, it is important to find an estimate value for the focal length of the converging lens. And we start with aiming our lens to a distant window, and we place a screen behind the lens to focus the image of the window on the screen. We move the lens forwards and backward until a clear real image is found, and we measure the distance from the center of the lens to the screen. In this case, we find that the focal length is about 16.5 centimeters. Now we start the experiment, and we are going to measure distances u and v, object distance and image distance. We produce a real image, and in order to do this, we must make sure that the object distance is greater than the focal length. The lens will produce a real image. We move the lens forwards and backwards, and we note that there will be two positions for a focused image. And we use these two positions as repeated readings for the image distance, the distance from lens to screen. We repeat the experiment for different values of object distances. We always make sure that the distances we choose are greater than the estimated focal length. We measure object distance and image distance. All the data is recorded in a table as shown, and from the table we can analyze using the lens formula that if we plot 1 on V against 1 on U, we will get a straight line graph with a gradient -1 and y-intercept as 1 all over the focal length.